Hello students, in today's class we are going to discuss about hypothesis testing. Now we will understand why hypothesis testing is very much important for data science. So hypothesis testing is a statistical method. It is used to make decisions about a population based on the sample data. So in data science, this hypothesis testing can be used to test whether a new model is better than the old one. Does this feature significantly impact the outcome? Is the observed trend real or just due to the chance? Okay, so these are some of the inferences that you can draw out of this hypothesis testing. So suppose you imagine that you have designed a recommendation algorithm and the old algorithm gives you a click-through rate of 8%. Okay. And now you have devised a new model. You have trained the model. You are deploying the model. When you deploy the model, you get the CTR for the new algorithm as 8.5%. Now, there is a significant increase in as of 0.5 percentage in the click-through rate. Okay, now you have to really test whether this 0.5 is real. Is it because of the improvisation of the algorithm or is it just a random one? Okay, you want to test it. Okay, in that case, we can go for a hypothesis testing. Okay, so we are going to learn hypothesis testing, how to do a hypothesis testing for some sample scenarios. Okay, what are the different steps of hypothesis testing? And how are we going to do that hypothesis testing for some sample scenarios is what we are going to see in this video. Okay. So hypothesis testing is you are going to test whether your idea is significantly better than what you have tried previously. So let us, for example, in the hypothesis testing, you will have a claim. You say that the click-through rate has improved by 0.5 percentage. Okay, you have a claim and you will test whether that claim is a true one or a false one. Okay, so you will have a hypothesis called a null hypothesis, which is your claim. Right? And then there is something called an alternate hypothesis, which contradicts that, okay, which should be an opposite of the null hypothesis. Let us take, for example, suppose that children in the United States watch an average of 3 hours of TV per week. So this is my claim. So I should have it as H naught. So this is the symbolic representation of a null hypothesis. I say that the children in the US watch TV for 3 hours. All right. And the hypothesis testing, okay, so the alternate hypothesis which is represented by HA can be, no, it is not equal to 3 hours. Okay. So there is also one more way of contradicting that. I say, no, it is greater than 3 hours. Or I can even say it is less than 3 hours. So these are the different ways by which you can contradict a null hypothesis. So we'll see with one more example. That is, it is believed that a candy machine makes chocolate on an average of 5 grams. So obviously my hypothesis, null hypothesis is mean average is 5 grams. Okay. And a worker says after maintenance, it no longer make 5 grams bars. So the alternate hypothesis is the average is not equal to 5 grams. All right. So hypothesis testing, the very, very important part of the hypothesis testing is the framing the hypothesis, the null hypothesis and then average alternate hypothesis. Now, what are the 4 steps for hypothesis testing? The 4 steps for hypothesis testing is step 1, you have to state the hypothesis. Okay. Step 2 is so the step 1 is you have to state the hypothesis. And step 2 is we are going to compute. We are going to set the criteria for a decision. So on what, how much percentage you are going to believe the null hypothesis. You can say, I'll be believing that for 95%. I'll be believing that for 90%. So you have to set the criteria. then you have to compute. Okay, there is a z-score that we are going to do it in this hypothesis testing. You have to compute and then you have to make a decision. So now as far as this hypothesis is concerned, there are two directions. Okay, one is the non-directional and the other one is directional. So what is directional? I say that all adults sleep 7 hours a day. So the alternate hypothesis can be all adults sleep more than 7 hours a day. So it is right side. Okay, it is, I say more than. So then the null hypothesis says all adults sleep 7 hours a day. So the alternate hypothesis can be all adults sleep less than 7 hours a day. So it is left side. Okay, so explicitly sometimes in the question, the right side or a left side is mentioned. Okay, so in that case, you can go for a directional based hypothesis. Sometimes a non-directional hypothesis will be given. It will be very explicitly given in the question, all adults sleep 7 hours a day. All adults do not sleep 7 hours a day. Okay, so in that case, you can go for it. Otherwise, you can choose any one. Either you can go for a directional hypothesis or a non-directional hypothesis. So here, let us see with this example. Doctor believes that the teen sleeps on an average no longer than 10 hours per day. Okay, so no longer than 10 hours per day, which means that very explicitly it is said that doctors have said the null hypothesis H naught is mu less than or equal to 10 hours. Okay, the alternate hypothesis is mu greater than 10 hours. All right. So very explicitly it is written no longer than 10 hours. So I am writing the null hypothesis in this way. All right. So the next step is we have to test the level of significance. Okay. We have to test using z-score. I'm going to test it using the z-score. So in order to test the level of z-score, I have a formula z is equal to x bar minus mu divided by. So we are using the formula z is equal to x bar minus mu divided by sigma by root n. Okay. So x bar is the sample mean and mu is the population mean and sigma by root n is the standard error. Okay, sigma is the standard deviation and root n is the samples. Okay, so you can use either, I told you, you can use the two-tailed test. Suppose you go for values such as you say that hypothesis mu equal to mu not equal to. In that case, you will go for a two-tailed test like this. Then if your z value lies in this region or this region, you are going to reject the null hypothesis. Only if your value fall within this region, you will be accepting the null hypothesis. And the next one is if it is a left tail test. Okay, so imagine this is your curve. If your value fall in this region, you will reject it. And sorry, it's a right tail test. If your value fall in this region, you will reject it. Okay, if it is a left tail, okay, if your z value fall in this region, you will reject it. This is your acceptance region. So we should be very clear about the statement of the hypothesis. Then the level of significance, mostly it will be given in the question. And then you are going for testing using this z-score. And then you are going to plot it on the curve. And after you plot it, you're going to decide whether you're going to accept it or reject it. Now we will discuss with some example problems. Let's have a look at this problem. A sample of 400 male students is found to have a mean height of 67.47 inches. Okay, so it said that you are taking a sample. Okay, let's take this. Okay, and I say the given values. First, let us write the given values. Okay, so you are taking a sample to be 400. Right? Then the sample mean X is given by 67.47. Okay. Then can it be reasonably regarded? Okay, can that sample value be accepted? Can be accepted. For example, the population mean is that is mu is, they have said as 67.39 and the standard deviation observed is 1.30. So they are asking, can this value be accepted? Okay, can I accept for 400 students? Can we say that the mean is 67.47? Okay. So first initially this. So now we will write the first step. We are going to write the hypothesis. Okay. So the null hypothesis said is, it is said, can it be reasonably regarded as a sample for a large population with a mean height of 67.39? So can that 400 male students data be considerably accepted, okay, and be equated to the large population calculation is what is the question. So I say that it is said that the null hypothesis we are going to state mu is equal to 67.39. Okay. But what we have got here is 67.47, which is greater than the 67.39. So I write the hypothesis in this way. Okay. The mu, the population mean given is 67.39. But alternate hypothesis, what they have received is it's greater than 67.39. Okay. So this is called, if I have written greater than, so this is called right tail test. Okay, this is called right tail test. Suppose I can even write this as two tail test saying that mu is equal to 67.39 and mu is not equal to 67.39. So I can even write this way as well. This is a two tail test. Okay. So now I'm going to consider the first case. Okay, I'm going to consider the right tail test and I'm going to proceed with the calculation part. Okay, we'll start with this. Here, the second one is you have to set the level of significance. You have to set the level of significance. Okay, so how do I set the level of significance? I say that it is given in the question that this is the second point. Okay, so you can set the level of significance. It is 5%. It's given in the question that it is 5%. So we are considering the right tail. Okay, so if the level of significance is 5%, so this is the value. Okay, so and as I go for the right tail test, one tail test, the value is 1.645. So I'll draw the curve. Okay, so say this is somewhere else called 1.645. Okay, fine. Now let us compute it. So the compute is z is equal to x minus mu divided by sigma divided by root 10. So x value is 67.47 minus 67.39 divided by sigma is standard deviation 1.30 divided by root of 400. Okay. So I get a value of 1.231. Okay. So if I plot 1.231, it is somewhere else around this point, 1.231. Okay. So now it has fallen in the acceptance region. So in a right tail test, this is called accepted region. This is called rejected region. Okay. So it falls in the accepted region. So I have to write the fourth step is I should write whether I accept it or reject it. So you can say that the Z value lies in the accepted region, AR, accepted region. So you are accepting the null hypothesis. So what is the null hypothesis we made? That is mu equal to 67.39. Okay, so yes, the population mean can be considered as the sample mean, which is calculated over the 400 male students. Okay, so we'll see one more example as well. So the next example. Okay, now we'll see this question. First, let us write the given values. All right. It is said that the mean of certain production process is known to be 50 with a standard deviation of 2.5. Okay, so it is said that the given values, if we write the given values, it is said that the mean is equal to 50 with a standard deviation of 2.5. Okay, 50, it is 50. Now, it is also the production manager may welcome any change in the mean value towards higher side, but would like to safeguard against decreasing values of mean. So, he's not convinced with the decreasing value of the mean. So, he takes a sample of 12 items. So, n equal to 12. Okay. And he found out that the mean value is decreasing. Okay. So, that is x is equal to 48.5. Okay. So, he felt that when he took a 12 items, it is 48.5. So now, what is the inference? Okay, should he believe on the samples or he should go for the population mean? So first let us I state the null hypothesis mu is equal to 50. You can straight away take the population mean and write mu equal to 50. And now when he tested, he has got the sample as 48.5. So I write mu less than 50. Okay, so it's mu less than 50. So this is the first step. Okay, so H naught, kindly use the symbol H naught HA, H naught colon, HA colon. And the second step is set the significance value to be 5%. Okay, so this is a left tail test. So obviously the value is 1.645. Okay, so if you draw the curve, okay, if I wish to draw the curve here, so you say this is 1.645. All right. Now we will compute it. Okay, so when you compute, z is equal to x minus mu divided by sigma by root 10. So which is equal to 48.5 minus 50 divided by sigma is 2.5 divided by root of 12. Okay. So this is a left tail test. So obviously this should not be this side. So this is wrong. So what will be the curve? It is something like this side. Okay. Minus 1.645. All right. So here I get a value of minus 2.05. So where will I plot minus 0.25? Somewhere else around here. It's minus 2.05. So this falls in the rejection region. Okay, this falls in the rejection region. So I am going to reject. So this is the second step. This is the compute is the third step. And fourth one is you're going to state. Okay, you have to say that whether you are rejecting or accepting. Here, clearly we have to reject the hypothesis. So what is the meaning of that? Yes, the mean is less than 50 is the correct one. Okay, we are going to reject the null hypothesis and accept the alternate hypothesis. All right. So we'll see one more question as well. An alternator manufacturer must produce the alternator. So first, very custom, we will write the given value, right? So with 95% confidence, it runs to less than 71.1 degree centigrade under stress test in order to meet the production requirement for sale to the US government. Okay, so it says that the alternator is running less than 71.1. Okay. The stress test is performed on random samples drawn from the production line on daily basis. Today, sample of 7 alternators. So for the first time, we were able to understand 7 alternators is done. And it has a mean. Okay, so X is 71.3. So when he did the population mean, it was 71.1. It was now he calculate for 7 alternator alone, he took and when he measured, it was 71.3. And sigma is equal to 0.214. Okay, so this was the first one. Now we will state it. The null hypothesis says mu equal to 71.1. If you are getting confused, straight away come and write down what is mu value here. Okay, and then based on the sample, you can decide whether it is a right tail test or left tail test or the normal test. Okay, so I just go here, mu is equal to 71.1. But x is 71.3, which is greater. Okay, so alternate hypothesis is mu greater than 71.1. So I have set the hypothesis. Okay, so if you are a little bit confused, I told you Straight away take the mu and write equal to 71.1. Find out what is the sample mean, and if it is greater, write it is greater than 71.1. If it is lesser, write lesser than 71.1. Okay, or even you can go for a two-tailed test saying not equal to 71.1. Fine. So set. The second one set, question itself it is set 95% of significance. So from the table, the value for 95% of significance is, the value is 1.645. Okay. Now we will compute. The third step is we are going to compute it. Z is equal to x minus mu divided by sigma by root 10, which is equal to 71.3 minus 71.1 divided by 0.214 divided by root of 7. So this value is 2.5. Now we are going to compute the curve. We'll draw the curve. This is 1.645 and 2 point will be somewhere else around here, 2.5. Clearly it falls in the reject region. Okay, the value falls in the reject region. So what should be the conclusion? The fourth step, you have to reject the null hypothesis. Very clearly there is a mark for it. So you should write the fourth step, reject null hypothesis. Okay, what is the conclusion there? Is there a production quality issue? Yes, asked. Is there a production quality issue? Because when I check the population, it is 71.1. But when I check the sample, it was 71.3, little bit higher. Production quality issue is there? Okay, yes, there is a production quality issue. So obviously you have to revisit the production quality to understand why there is a variation between 71.1 and 71.3. Okay, so I have solved 3 sample problems and few more sample problems is given in this PPT. So I just leave all the students an assignment that you will solve those questions and submit it in your assignment book.